Hello, this is Mr. Leaforth, and
Joe.
we're going to do a quick bug problem, particle problem. They're all pretty much the same. Basically, this is the velocity of a bug given right here, and the velocity is 10t minus 40, and we're going to graph that. So, Joe, do you know what the y-intercept is? The y-intercept is the number that's all by itself with no t next to it. Negative 40, right? Yeah. You gotta say it a little louder so that they can hear you. And then if you go up 10 over 1, up 10 over 1, up 10, because it's a positive 10 is the slope. It's not the perfect picture here, but we are going to cross right at about
4.
4. Alright? Because the slope is 10, you start at negative 40, 10 over 1, 10 over 1, 10 over 1, 10 over 1. So 4. And then this is negative 40. Alright? So sketch V, done. This is V at t, this is the velocity graph, and so we'll be learning a lot from that. We also have some information here about the position. The position at 0 is 37, so the bug starts at 37. Positive, moving to the right, positive velocity, that's going to be important as well. Alright, for what values is the bug moving left? Well, if right is positive velocity, so that's over here, then this is the negative velocity. So for what values of t is the bug moving left? Well, starting at 0, right?
Mm-hmm.
And ending at 4. Now, the question is, should we have hard brackets? No. We don't really know necessarily what's happening before. Well, I guess it goes through. Well, I would probably do soft brackets. That's probably safe for something like this. Find x at 10. Find the position at 10. Well, if you want to find the position at 10, I need some more room here. But basically, the position at 10 is the change from 0 to 10 of this equation, 10t minus 40. And then where did we start at? Somewhere here it told us where we started. We started at 37. And so this is important. You got to do 37 plus the change from 0 to 10. Alright, so we can do that in our calculator or by hand. 37 plus, what is it, 10t squared over 2 minus 40t. And we're going to evaluate from 0 to 10. Here's where you can help me out, Joe. That's 37 plus 10 divided by 2 is
5.
t squared minus 40t. And the rule says that you plug in 10 and you plug. Wow, it disappeared. Obviously, this isn't my best video ever. You plug in 10, you plug in 0, and see what you get. So 37 plus 5 times 10 squared minus 40 times 10. Alright, that's the first piece when you plug in 10, and then you do minus 5 times 0 squared minus 40 times 0. So I'll need your help with some of these calculations. So we get 37 plus 10 squared. What's 10 times 10?
10. Or 100.
Times 5?
500.
500 minus, what, 400? So that first parentheses is going to end up being 100 minus 0 squared times 5. That's nothing. This is nothing. I think it's minus 0. So I think we're going to be at 137. So if you scroll back up, it's 137. This is centimeters per minute. So it's got to be 137 centimeters. And that's positive. So it's 137 centimeters to the right. Okay, now we did that fast. You can scroll back through and see if there's anything we need to change with that. Alright, well that was probably scary. It just kind of magically appeared at a different place. But we're doing D now. When the bug's velocity is 15 centimeters per minute, when the bug's velocity is 15 centimeters per minute, what's its position? So we need to think about that one for a sec. So the formula for velocity is, hopefully that didn't get recorded. Formula for velocity is 10t minus 40. and the velocity is 15. And the question is, when the velocity is 15, when does that happen? So we add 40. Let's try you again, Joe. What's 15 plus 40?
55.
And then dividing by 10. 5.5, I think, right? Alright, so that was strange. I wasn't expecting that to happen. So how do you figure out what his position is? Well, again, we started at, oh man, I'm getting old. We started at 37, and then we do the integral from 0 to, what is this? 5.5. Alright, and so how do you find out the position? Where does it start, and how does it change? Last time we did it by hand. This time, we'll be a little lazy if we can and do it on the calculator, if we can turn our calculator on. So what I want to do is plug in that, do you remember the equation? What is it? 10x minus 40. Alright, and so we put out of there, we go math 9, and it's variables, y variables, function, and y1. With respect to x, we want to start at 0, we want to end at 5n a half, and that's that, and then you add to that 37. And so what's the position? It's, what is it?
Negative 31.75.
The velocity, negative 31.75, what's that, 3/4? And that's the position, and that's centimeters, and since it's negative, to the left. And so that is what we got there. Now, I'm a little worried, Kaplan wrote this out, I'm a little worried about that 5.5. I can look back at it later, we might have tweaked something in there, but we're fine for now. The next question is find the velocity from 0 to 10. Alright, let's just go back and entry. So instead of going from 0 to 5.5, we'll type in 10. And let's see what that is. 100. I feel like we already did that somewhere. But okay, so we got 100. Let me erase all of this stuff. So we did in our calculator the integral from 0 to 10 of the v of t dt, and we got 100. So what does that mean? So that means the change in position of the bug. So we need to talk about, sorry about that, the change in position of the bug from time 0 watts, 0 watts, centimeters per minute, thanks, yeah, you're younger than me, 0 minutes to 10 minutes. The change in position is 100 centimeters, and it's 100 centimeters, it's a positive 100 centimeters, so 100 centimeters to the right. So basically, during the first 10 seconds I'm looking at it, the bug moves 100 centimeters to the right. Okay, we got all fancy with it, but that's basically. Now, what distance did the bug travel? Well, the change in distance was 100, but what distance did it travel? We'll probably have to split that up, because what happens here is it goes to the left over here, and it goes to the right over there. So where does our split happen, Joe? Okay, he said right there and pointed, which I know you guys out in the airwaves can't really figure out what that is. So where are you pointing to, Joe? Okay, right at 4. So what we want to do is integrate. Sorry, it keeps jumping around on me today. Alright. So, let's get rid of all this stuff. I'm glad you're watching me get rid of all this stuff. Hopefully it doesn't sound like a bunch of scratching. Anyways, basically, for the distance, the key is this. This is the change in distance, but when we want total distance, you want to integrate from 0 to 4, and then add that to the integral from 0 to, from 4 to 10. Alright? And so we're going to do that for the velocity. and we do that for the velocity. Now, this answer, let's just do it. You'll see that the first answer is going to come out to be negative. So, last entry, instead of 0 to 10, let's just do 0 to 4.
Yep.
And that's negative 80. And I'm not surprised that it's negative 80. Oh, we could have just done that, based on the triangle too. We could have just used geometry. But I knew it was going to be negative because it was below. We know it's traveling left. Everything we know kind of makes sense. And then you do entry again, and this
0
time...
to 10.
So we
Or
did
4 to 10.
4 to 10. You did the same thing I did. Like father, like son. They say the apple doesn't fall too far from the tree. So we can see why the change was 100 overall. So you go negative 80 to the left, and then 180 to the right. So the change is 100.
Yep.
But I want to know, like, not the change, but how far did it go overall. So basically, we want to take the absolute value of that and the absolute value of that. So Joe, we got 80. Well, that means my time's up. We got 80, and then 180. And so what's that going to add up to be?
260.
260, and that is centimeters, and this is the total distance. So this is like a key problem where we talk about the difference between total distance. So that's how far did you go to the left, how far did you go to the right. It's like having a little pedometer on. And the other way is just looking at the position you're at. So it's 100. And so the integral, the question for E here, the integral is what we want to look at when we want the change in position. And for the other one, we want to look at absolute values. We're usually splitting it up, and that's going to tell us the total distance traveled in 10 minutes. And so that's a pretty decent bug or particle problem, and I would be ready to do something like that in the not so distant future. Joe, you got any last words or anything like that? Do you
No.
like bugs? What do you like more, bugs or particles?
Stop video.
All right.
Delete them.
Thanks for listening.